types of maintenance, and there is an associated layman's law related to the software, and we will look into the maintenance process model, some reliability, and we'll look into some common reliability matrices. Okay, so let's start with maintenance. So all of you know very well that this phase normally starts after the software goes live. So this is the last phase in the software development life cycle, but it's not a developmental phase, because this is one of the most important phases, because once the software is completely built, this phase kicks in. Okay, and this is the most important period of time, because during this time, even though with a lot of testing and everything which is carried out before the software is accepted, a lot of maintenance activities are done. Now, maintenance activities involve correcting issues and bugs which were not identified during testing, or for that matter, enhancing the system, or even adapting it or porting it into a new environment. So based on this, we have 3 different types of maintenance. So the first one is corrective, wherein all the bugs which were not discovered during the testing phase and were found out after the system was released into the production environment, those are corrected and fixed. So that kind of maintenance is called as corrective maintenance. The second type of maintenance is the adaptive maintenance. Now this is done when probably you need to port to a different environment. For example, if you have your systems configured to, let's say, a Windows, and you want to move it into a Unix operating system or a Mac operating system, or for that matter, if you're using a different version of your database or a different database and you want to port it to a different database. For example, if you have used MySQL as an open source database and now you want to port it into Oracle, so you need to change certain code, you need to basically make some changes, right? Now all that is done under the adaptive maintenance. And the third is basically perfective maintenance, where we basically look at enhancing the functionality of your system. So if there are certain new features that need to be built into the system, right? So this is done under perfective maintenance. Now every software, you have realized and that softwares keep changing, right? So the characteristics of software has been defined by the layman's law. And layman says in the first law that a software product must change, otherwise they will become less useful. Now you must have noticed that this is true. If there is a application which you install on your system, and if there are no updates, there are no changes in that application, people start getting bored of it. So every app or every software keeps enhancing itself. So a software product must change continuously, otherwise they will become progressively less useful, right? So as and when new features have to be added into the system, you cannot have a software which has no changes and it runs continuously for years, right? You need to have, even look at softwares like Instagram and Facebook. They are constantly trying to evolve. They always bring in new filters, new different types of modules into them, so that people are do not get bored out of it. And they add a lot of useful features as and when it's required, and they release it in different packages, right? So this is what layman's first law states, that a software product must change continuously, otherwise they will become progressively less useful. The second law is, as and when you make changes to the program or the software, the structure of the program slowly degrades. Okay, so the more maintenance you carry out, you're basically trying to shake up the existing structure on which that system was built, right? Just imagine, like, if you have a new car, with regular maintenance, when more and more maintenance work is done, if you enhance features, if you add certain functionalities to it, if you keep repairing things, right, slowly the overall structure will degrade. So this is what the layman's second law tells you. Now the third layman's law tells you that the rate at which code is written during the coding phase and the rate at which the coding is done during the maintenance phase, both are same. That means the effort it takes to write or make a new software and the effort it takes to maintain a software is basically the same. Okay, so these are the 3 laws of layman: which are basically related to the characteristics of software evolution. Now, when we talk about maintenance, right, we talk about, let's say, change requirements. So sometimes what happens is when you have certain additional changes that need to be done into your system, then if the changes are very small, right, and if basically the requirements are not very complex, then we use the first method, which is listed here. But if the requirements are complex and you do not have any documentation for the existing requirement, right? Suppose you have built an application without any process, without any documentation, without any design, without, a proper design diagram or an architecture, and if the requirements are complex, then we use the second method. So the first method is very simple. What we do with first method is take the requirements, right? So basically you gather the requirements. When you talk about requirements here, we're talking about the change requirements, because these are the additional requirement that you're going to add into your existing system. Or if you want to change the functionality of an existing system, then also we actually follow this process of, change requirements. So you gather your change requirements, do the analysis of the requirements that you're changing or you're adding. You also make code strategies. That means you make strategies on how to change the existing code to implement the new requirement which has come, and then you apply the changes to the old code, right? So you basically make changes to the already existing code, and then you integrate and test. And once this is done, an important point is that you need to update all the documents with the changes that you've done. So if there was a design change, you'll have to go and make changes into the design and also basically create a new version of the design document with the new changes that you have incorporated. Alright, same thing, you have to go back and update your SRS with the new version, wherein you need to write explicitly what changes you have done. So these are all related to the first method, and the first method is basically used when the requirements are small and there are changes are very small and it's not complex. There are apt documentation available for making the software or understanding the software. Now the second method is used when you don't have any requirements, or when you don't have any documentation for an already existing project. So in that case, thus making changes into your software becomes a little bit more challenging. How it becomes more challenging? Now when a new requirement is basically brought into the picture, then what we need to do is, it's very difficult to incorporate into the old code, because you don't have any documentation, you don't know exactly how that code is going to hamper. So what we do is, we have to do something called as reverse engineering. So in the process of reverse engineering, so you already have this existing code here. From the code, we try to figure out which are the modules which are there in the program. So that means we do a reverse engineering. We look at the code, identify all the modules from there, then try to make a rough design of those modules. So basically you create an architecture of your system from the module specifications, and after you have the architecture of the system, you have to write down the SRS, the requirement specification, from the design. So basically we are going backwards, right? The normal process is take the requirement specification, do the design, do the module specs, and then do the coding. But in this case, we look at the code, because the code is available to you without any documentation, and we try to create all the documentation which is required for the software engineering. And then after you get the requirement specification, you plan to add the new requirement specification in the form of changes to the old existing requirements, or adding new requirements to an already existing software. And then you use the forward engineering process. That means once you incorporate your new requirement specification, then on the basis of your new requirement specification, right, and your earlier design that you have got, you make changes to the design, then you get your module specs, and then finally you make changes in the coding. So in this scenario, when the requirements are complex and there is no documentation available, there is no module level information, there is no design, there is no requirement specification, you have to create all of this once again from the back, which is called as reverse engineering. and this is called as forward engineering. Okay, this is called as forward engineering. So in the second method, which is more complex, the requirements are first kept on hold, and first reverse engineering is done on the software which already exists, and then we get to a phase wherein we get the requirement specification, design and all the documents, and then we start making changes into that document that we have actually brought into the picture, and then do the forward engineering and incorporate all the changes into it. Okay, so this is the second method of doing or managing the changes in the maintenance phase. Right, now when we talk about the maintenance, we talk about reliability. Okay, what is the reliability of a software product? Now reliability is a non-functional requirement. Now obviously all of us want things to be more reliable. Okay, reliable means that your product should not fail, right? It should be reliable. So if your product is highly reliable, that means that when you're using it, there are very less chances of it failing. Okay, now the problem with software reliability is it's a very difficult kind of an attribute to measure. Okay, when you talk about hardware, it's an easier way to measure a hardware reliability, because hardware failures are different from software failures. Now most of the hardware failures are due to the actual machine or the components wear and tear. Like for example, when you are using a mechanical device, like over a period of time, due to friction and due to wear and tear, it will fail. And it's easier to fix a hardware fault, because if due to wear and tear, if it fails, then what you do is you remove that part and fix the new part, and it's easily fixed. But software faults are not very simple. Okay, softwares, they don't have wear and tear. So until you make changes to the software design and the code, the fault will continue to fail. There will be a continuous failure. So to identify why it is failing, you need to actually do a lot of analysis. Not like a hardware where you identify, oh, this part has a problem, replace the part. But in case of software, you have to figure out where exactly it is failing, right, is a challenge. So until you make changes to the code, to the design, and fix that actual problem, which could be related to some code somewhere, the system will continue to fail. So hardware failures are different from software failures. Hardware failures are easy to fix. Hardware failures are easy to identify. Software failures are a little bit more challenging. Okay, so the question now is, how do we measure the reliability of a software? Okay, now reliability is also is a part of the non-functional requirements in an SRS, and there are certain metrics by which we can measure the reliability of a software. So I have listed down 6 here, and these 6 are important. So what are these metrics? Let's look at each one of them one by one. So the first one here is rate of occurrence of failure. Now rate of occurrence of failure is a metric which basically tells you that over a period of time, how many times the failure has occurred, right? Very simple. So you can say that in 1 hour, 3 times it is failing. So 3 failures per hour. Okay, it's very simple. So rate of occurrence of failure is the frequency of occurrence of failure. That means whenever we talk about frequency, we are talking about time here. Okay, so over a period of time, you calculate the total number of failures, and that gives you the rate of occurrence of failure. That's number one. The second one is, suppose the software is running fine, right? What is the average time between 2 successive failures? Now what happens is, you basically measure the different time intervals during which the software is failing. So suppose the first failure occurs at time, say like t. The second failure occurs at time t plus 3. The third failure occurs at time t plus 8. Fourth failure occurs at time t plus 15. So what you do is, to find the mean time to failure, you average out all the time between 2 successive failures. Okay, so suppose if this is the case, the software fails here, then the software fails here, then the software fails here, and the software fails here, then you basically take the average of 2 successive failures. So you calculate the what is the time between the failure of software here. So suppose this is 3 hours, and suppose this is 5 hours, this is 10 hours. So you basically, find the average of this, and that will give you the mean time to failure. Okay. Now the next one is mean time to repair. So let's say that the software is running fine, and here there's a failure. Okay. So this is the place where the software has failed. Now once the failure occurs, it will take time to fix it. So during that time, the software will not be running. So suppose at this point of time, the software has failed. And then this is the time which is taken to repair it. And at this point of time, the software is repaired and again it is running fine. Okay. So what is the time taken to fix faults? So this is the time which is taken to fix that fault. That is called as MTTR. That means mean time to repair. So how do we calculate the mean? So you basically observe the software over a long period of time. So in this case, suppose mean time to repair was 3 hours, let's say. Then again a failure occurred here, but it took more time to repair. So failure, repair. So this time it took 5 hours. Then again it failed here, and it took another 2 hours to repair. So the mean time to repair will be the average of 3 plus 5 plus 2. Okay, so mean time to repair is basically the average time it takes to fix the faults. Now there is another kind of matrix called as mean time between failures. Now what happens is, say the software is working fine and here is a time when it fails. Then again it takes some time to repair. So here is a failure, here is a repair. Okay, and this is the place where the software was repaired earlier. So again the software runs fine, and then it fails here, and then it takes some time to repair. Okay, so if you combine this plus this, it will tell you that after the failure has occurred or the repair has been made, when would the next failure occur? What is the probable time when the failure will occur? So if you calculate the mean, so basically this is MTTF, mean time to failure, and this is MTTR. So if you combine these two together, that is basically the time which basically tells you that the next failure can be expected after this mean time. Okay, so a mean time between failures, that MTBF, is basically combination of this plus this, which can tell you that suppose you have MTBF of 100 hours, what this will indicate is that once the failure has occurred, right, the next failure is expected after 100 hours. Okay, so that is basically what MTBF gives you. So to just put it simply, mean time between failures is the sum of mean time to failure and mean time to repair. Okay, and then you have POFOD, which is probability of failure on demand. Okay, now in this case you don't have any time aspect. In this case what happens is, when you have a service request, so you basically look into metrics of transactions. So for example, if you're in shopping on an Amazon system, so for an Amazon system you can probably calculate the probability of failure on demand. That means if suppose there are 1,000 transactions being done on the Amazon site, out of those 1,000 transactions, how many are failing? Okay, so a probability of failure on demand of 0.0001 means that 1 out of 1,000 service requests may result in a failure. So if you have a POFOD value, which is probability of failure of on demand value of say 0.1, this will indicate, right, that 1 out of 10 transactions or 10 actions will fail. So if you click on a button 10 times, then 1 time it will fail. Or if you carry out 10 transactions, out of those 10 transactions, 1 will fail. So 0.01 will indicate that out of 100 transactions, 1 is going to fail. Okay, so this is a metric which does not involve time. And this is used in transactional based system, like when making banking requests. So in that case, they check for probability of failure on demand. Okay, and the last one is the availability metrics. Now this is important for systems which need to be, available 24/7. For example, the telecommunication system, operating system of servers, right? So if you are running a web server or a web application, for example, Google or Twitter or Instagram or Facebook, these kind of applications should not have any downtime, because even if they are shut down for like 1 minute, there is a huge hue and cry. So availability is a metric which is important for all systems which have real-time data processing, okay, and which are being used across the world 24/7. So most of the systems availability basically is given by percentage. So you will find that on web servers you'll have like this, my domain or my hosting server will give you 99.5% availability, or someone will give you 99.9% availability. No one can guarantee you 100% availability. That means there could be an instance where your server is down for even a small instance of time. Okay, so when you are actually trying to host your application on any server, you will find that when you're going to buy the hosting space, they will advertise that our hosting is, we give you 99.9% availability. That means there's chances of your, the server on which you're hosting your application will be available for 99.9% of the time. Okay, so availability is an important metric for web-based systems, telecommunication systems, operating systems on servers which are not supposed to be shut down ever. For example, banking transactions happen across 24/7, right? Or for example, ticket booking, airline booking. So these kind of systems need a very high availability. So higher the number of availability, better the system is. Okay, so this chapter has got only this much. So you need to, study only this much for your exams. So what I would want you to do is go through each one of the slides. If you're not able to understand that, please ask me. Send me a message, call me, or send me a message on the group. I will, explain that one-on-one if you want. Okay, so this is basically the second last chapter. There is one more small chapter which I will just either teach you in the class, or I'll make a video of it and give it to you in case you have too many classes and exams and all going on, right? But till then, you just study this and please ask me if you have any doubts. Okay, so I'll see you in the next class. Bye bye.